All right, today we're going to work on lesson 1.5, which is locating points on a number line. Um, it's not quite as easy as it may sound. It's not all that tough either, but our job is going to be is to locate a point on a directed line segment or on a number line that's a fractional distance from the initial point. And we're also going to work on locating points that will partition a line segment into a given ratio. So we're going to jump right into it here with our first example. And this is on locating a point on a number line given the length of a segment and another point. So once you see it laid out, it's pretty straightforward. This just says suppose that y and z are points on a number line. If yz equals 14 and z lies at 7, then where could y be located if there's more than one location separated with commas? Okay, so what we know here is the distance from y to z is 14, and we know z starts at 7. So if y is going to be 14 units to the left of z, all right, then y would be found as follows. I would take the 7, which is my beginning point, and subtract 14. That would move it 14 units to the left. 7 minus 14 is 7 plus negative 14. That's negative 7. So y could be located at negative 7. If y was 14 units to the right of z, all right, then y would be found by adding 14 to 7, my beginning point, add 14, and that's 21. So as you can see, if I want to move from a point to the left, I'm going to subtract the quantity. And if I want to move from the point to the right, I'm going to add the quantity. Now looking at it graphically, it looks like this. So if here's my z, it's at 7. If I go 14 units to the left, I'll be here at negative 7. That's 7 minus 14, negative 7. If I go 14 units to the right, then I'm going to add 14 to the 7 and get 21. So the two possible locations for y are negative 7 and 21. You got to remember that you can go to the left of that number and to the right of it. Okay, another example along this lines. So now we know r and s are on a number line. The length of rs, or the distance from r to s, is 13. S here is at negative 8. All right, so where could R be located? I think by now we get it that there could be two possible locations. One when we move to the left of S, and one when we move to the right of S. So kind of mapping that out, if R is going to be 13 units to the left of S, then I'm going to take the negative 8 and subtract 13. To move 13 units to the left of negative 8, I subtract 13. Well, mathematically, that's the same as negative 8 plus negative 13, which is negative 21. So the location of point, R, could be at negative 21. Now, if I want to take R and go 13 units to the right of S, which is the other possible location, then I would take negative 8 and add 13. So that would be at positive 5. Graphically, it looks like this. So here's negative 8. Okay, that's our beginning point. That's where S is located. If we go 13 units to the left, R would be at negative 21, and the distance from R to S would be 13 units. If I added 13 to S, I'd be over here at positive 5. So there's the other location for R. And you can see the distance from S to R is 13 units. Okay, both of these are answers. So the possible answers are negative 21 and 5. Okay. All right, next kind of question is when we have to partition it on a number line, or partition a segment on a number line. So let's talk about what this says here. It says in the figure below, or to the right here, n lies between m and p. So m is at negative 27, p is at negative 9, and we know n is somewhere between these two. Okay, our job is to locate n so that it is 1/6 of the distance from m to p. I want m to n to be 1/6 of the total distance of m to p. So we got to figure out where to put n to make that happen. Well, the first thing we need to do is figure out what is the length of MP. So how far is it from M to P? Well, by now you should know to calculate the distance on a number line, we take the absolute value of the difference of those values. So negative 27 minus negative 9 is really negative 27 plus 9. That's negative 18. And then the absolute value of negative 18 is 18. So I know the distance from M to P is 18 units. Now we want the location of n to be a sixth of that distance. Okay. So what we need to do is find a sixth of 18. What is a sixth of 18? So mathematically, it's 1 over 6 times 18 over 1. We can cross cancel, divide both these by a 6. We get a 3 and a 1. And then multiply it, we get 3. So what we know is we need to locate n 3 units to the right of m, and that will make mn 1/6 of mp. All right, so how do we locate n 3 units to the right of m? Well, we just worked on this, right? If I want to move it 3 units to the right, I'm adding 3. So negative 27 plus 3 is negative 24. So we now know the location of n is at negative 24. The distance from m to n would be 3, right? Negative 27, negative 24 is 3. M to P we already know is 18, and 3 is 1/6 of 18. So that's the correct location. Okay, another way of asking that same question is to give you a ratio like this. So in the figure below, B is between A and C. So A is located at negative 28, C is here at negative 8. We know B is somewhere in between these two. We got to find the location of B so that the ratio of A to B and B to C is 3 to 1. So obviously A to B has got to be 3 times as much as B to C. Okay, that's what we're trying to get here. So what do we start with? Well, better find the length of AC first of all. How far is it from A to C? Well, absolute value of the difference of their coordinates. Doesn't matter the order in which you subtract them. So I went negative 8 minus negative 28. That's negative 8 plus 28. That's 20. So that's, excuse me, absolute value of 20, which is 20. So I know the distance from A to C is 20 units. Now I want to break it in a 3 to 1 ratio. Now what that means is a 3 to 1 ratio means there are 4 equal parts. Okay, I want A to B to be 3, C to be 1, so it's got to be 4 equal parts here. Since it's going to be 4 equal parts, I want to take my distance from A to C and divide it by 4. That answer is 5. So each of these equal parts is going to be 5 units. I want to mark off 5 units, 5 units, 5 units. Okay? Get the desired ratio now. B's got to be 3 times 5 because I want it to be 3 to 1. So 3 times 5, 15 units to the right of A. How do we move to the right of A? We add 15 to it. So A's at negative 28. I'm going to add 15. That puts me at negative 13. Okay, so if I look at it now, A to B compared to B to C is 3 to 1. The distance from A to B is 15. The distance from B to C is 5. 15 to 5 reduces 3 to 1. So that's how we got it located, and B should be at negative 13. So you're going to get a variety of questions that look like those tonight. It's going to be on your Alex link. So make sure you get to your Alex link and work on solving these questions. It's really just based on these 3 different types. You can also go to your McGraw-Hill textbook, and there's more definitions, examples, and sample questions there for you to work at. All right, go get them.